Hello and welcome to my channel The Complete CSC Guide. I am Sanskriti. Now today I will teach you a different topic that is about IPv4 addressing is in computer networks, and it's a totally different topic since it's uh, about your addressing, how we different addressing, classless addressing and classful addressing, they have been classified. Okay, so before seeing that thing about the classification of those addresses, we have to go through the whole chapter of IPv4 addressing. There is also an addressing which is IPv6 addressing that we will see in other classes. But today the topic is IPv4, that is your IP addressing. It's about the internet protocol, about the IP addressing. In this IP addressing, this IPv4, IPv6, these are the different versions. Okay, so today's our main topic is IPv4 addressing, in which we will see the different things like classless, classful, this kind of addressing. Okay, so let's start. And these addressing are mainly very important since these are internet protocol. This addressing are very important, and their versions are also important. And in between these, each and every addressing means each and every addresses, the IP addresses, how they are being classified, how they are differentiated, and how they are being given to different users, how these addresses are being assigned to different users also. This thing you will also come to know about. This all things you will come to know after we complete this chapter. Okay, so let's start the chapter. What is IPv4 addressing? So what is an IP address? First of all, the main thing is about IP address. What is an IP address? Before we study about the IPv4 addressing, we have to know what's an IP address. Okay, so each host on a TCP IP network, when we are using a TCP IP network, there you have already studied the TCP IP protocols, and the layers, different layers we have already studied in our different classes. So you can see those in your previous classes, that particular video where I have described about the TCP IP layers. So you can see there in the OSI model layer also that is described there. So today only let's see about an IP address. Okay, you can see the whole video of that TCP IP where you will get the idea. Okay, now let's see. Each host on a TCP IP network is uniquely identified at the IP layer with an address. Okay, so whatever a host is, a particular host, each and every host, when we are using the internet, so we will be called as a host. So each and every host, they are being assigned some address, that's your IP address, right? So you have studied about this IP address many times. You come to know about this particular IP address. You listen to this particular term, that is this IP address. What's an IP address? That is the fact here. So each host on an TCP IP network, when you are working on a TCP IP network, there you will see that there's an uniquely identified, each host is uniquely identified. You will have an unique identification whenever you are using the internet, right? So at the IP layer with an address, that particular address which is being assigned to you, and that particular address which is identifying you as a unique particular host, that particular address is known as your IP address, right? An internet protocol IP address specifies the location of a host or client on the internet. So this particular IP address, that is your internet protocol address, IP address, right? That is, it specifies the location from where you are using the internet, of a host or the client on the internet, whosoever is using the particular internet. So which internet whenever you are using, so which person is using, which client is using, that particular thing is been assigned, they are been assigned a particular unique address. That each and every client is given an unique address, and that address is known as your IP address. Okay, so this is the internet protocol address. This is about your IP address. So each host will have this address. Okay, now where do IP addresses come from where we are getting these IP addresses? So here you can see there are some standards of IETF, that is your Internet Engineering Task Force. Okay, so this is where these IP addresses start from, that is your IETF, right? Now that's our standards. Next is for allocation, that is being done by the Internet Assigned Numbers Authority, that is your IANA. Okay, and then after that, that is your Asia Pacific Network Information Center, that is your APNIC. After that, ISP, and which is doing the assignment, and last is your end user who is getting the IP address. So this is the whole process or whole path how you are getting the IP address, right? So here IP and APNIC is the regional internet registers, that is RIRRs, which are distribute the particular version, that maybe it's IPv4, IPv6 and AS numbers to the internet community. Okay, now Indian Registry for Internet Names and Numbers, IRINN, is the particular thing where the allocation is done. So here this is the whole path how you get the IP address for you whenever you are using the internet. For a client or for a host, this particular IP address, after coming from this path, we get the IP address for the unique identification, right? Now let's see this is the thing. Okay, now regional internet registries that we have already studied. So you can see here which country uses which regional internet registries. So this I have shown here. There is Asia, ARIN, and here APNIC, that is for here. And again you can see in America also RIP, RIPE NCC is there. Africa is AFRINIC. So these are the different regional internet registries. Okay, so you can see here which country uses this one. You can also search in the internet also. So different countries, they have different regional internet. For India, it's Indian Registry, that is IRINN, that is NN. So Government of India, Department of Electronics and Information Technology enrolls the operations of National Internet Registry, that is NIR, to National Internet Exchange of India, NIXI, that is NIXI. So this is Government of India, which Department of Electronics and Information Technology, they have enrolled that particular operation by the NIR or to the National Internet Exchange of India. Now NIR is an entity under the umbrella of a regional internet register, that is your RIR, which is Asia Pacific Network Information Center, APNIC. NIXI was recognized by APNIC in March 2012 to become the NIR for the country. The NIR has been named as Indian Registry for Internet Names and Numbers, that is IRINN. Indian Registry for Internet Names and Numbers. Okay, so whatever names and numbers we get on the internet, that is being registered by this particular thing. Now IP addressing, we have two kinds of addressing which we typically do, that is your IPv4 and IPv6. So which I have already told you. Now this class is for IPv4, but I will tell you what is IPv6 also. Okay, so IPv4, the total length of IP is 32 bits, but in IPv6 it is 128 bits. Okay, now address space for IPv4, that is your 2 to the power 32, and for your IPv6 it is 2 to the power 128. So this is the address space of IPv4 and IPv6, and this length of the IP internet protocol for IPv4 is 32 bits and for IPv6 is 128 bits. Okay, so it is the basic thing about your IP addressing. Okay, now let's come to IPv4 now. IPv4 address scheme. Two types of addressing schemes are there. One is classful and one is classless. Okay, so two kinds of addressing is there in IPv4, that is classful and classless. Okay, so classful, original style of addressing based on the first few bits of the addresses, generally used in customer sites, right? Customer sites, these addresses are used, that is your classful addressing, where the original style of addressing is used. Based on that, first few bits of the address are being used. Okay, now in classless addressing, a new type of addressing that disregards the class bit of an address and applies a variable prefix mask to determine the network number. This is another scheme, right? So in the classful addressing, the first few bits are taken, and classless addressing is a new kind of addressing scheme where it disregards the class bits. Okay, and it applies of an address and it applies a variable prefix mask. Okay, which determines the network number. Here this mask is used, which is a prefix number which is used to define the address. But in Classful, the bits, first few bits are being used. Now, the address can be expressed in decimal, octal, hexadecimal or binary. I hope you have already learned about these things in your digital classes. So decimal, octal, hexadecimal or binary, these can be the address. IPv4 addresses can be expressed in these particular number systems. Okay, now most common IP address form is dotted decimal notation. We use the dotted decimal notation to express this addresses. Okay, that is decimal equivalent of each bit is separated by a dot. In decimal, the address range is 0.0.0.0 that you can see. This is the starting range of the addresses and the ending range is 255.255.255.255. So this is the whole range from 0.0.0.0 to 255.255.255.255. So this is the whole range in which this IPv4 addressing falls. So whatever will be your number, that number will be from 0 to 255 in this whole notation. Okay, that is your decimal notation, where you can see by each dot the address is separated. We will study now what is that. So this one is the decimal notation, right? Now next is, okay, so one more thing, here it is dotted decimal notation. Okay, so you have to see that each and every, before the dots, whatever things are there, you have to see each and every number that should be perfectly given when we are going to express the address. That is very important. Okay, now let's see. So two types of addresses are there now. Again, classful and classless. Classful is original style of addressing based on first few bits, and generally this is customer. Okay, again this is coming. So classless is there, classful is there. So we have already studied this one, and here it is about, okay, now IPv4 classful address scheme. There are 5 classes of addresses, that is A, B, C, D and E. This is the thing which is very important in case of your classful addressing, that is your A, B, C, D and E. These are the different classes in which the addresses have been differentiated or it had been distributed. The range we have seen, that what was the range, from 0 to 255, which was the range. But again, after that particular range, that also from 0 to 250, that is also being divided into these different classes, that is your A, B, C, D, E, this particular class, that is your 5 classes. Now A, B and C classes are used to represent host and network address. For host and network address, this A, B and C class is being used. Class D is a special type of address used for multicasting. I have already told you that different users and for different purposes, this class full addressing, these particular classes are being used. These classes of addresses are being used. ABC for your representing a host and a network address. C is C up to C, and then up D is used for your multicasting purpose, and E is for reserved for experimental use. So this is how the classification of addresses is done. Okay, that is your A, B, C, D and E. Now here you can see that how this A class, this bit is taken, B, this bit C, this bits and these bits are being taken. That is your network number. Network number assigned by IR. That is your Indian registry. So in classless, classful addressing, for class A, first bit, second these 2, these 3. For multicast and for research, D and E. And H is the host number assigned by network administrator. So here it is the H which is assigned by the network administrator. And what is that? That is your host number. So first one is your network number, second one is your host number. And this is the whole classification, how we will be breaking this one. For class A, the network number and other will be the host number. For class B, 2 will be network, 2 will be host, and for C, 3 will be network and 1 will be host. This is the partition, or this is how we distribute the whole address, whole each and every bit. Okay, now let's see. And D and E are for reserved multicasting and research purposes. Now here, identifying a class of an address. Now you have an address, you have an IP address. Now how will you identify which particular address is of which class? Then only you will be able to understand that it is for which kind of purpose, or it is for used for which purpose, right? So address identifier, network address and host address. How we will identify? Now we have an address. First of all, what we have to see, for it the address to be in class A, of class A, what you have to see, the first bit will be 0. After that, 7 bits will be network address and 24 bits will be host address. This is the identification of your class A address, right? Now, if it is of class B address, first bits will be 1, 0. It's in the binary form, right? Now, then will be 14 bits network address and 16 bits host address. Now, so C, it will be 110, that is 110, sorry, 110. 21 bits will be network address and 8 bits will be host address. For class D, which is for multicasting, 1110, then will be multicast address, the whole address. And for E, it will be 1111, and that is reserved for future use. So it is the whole classification, how you can identify when you have an address, how you can identify the whole address, right? Now here let's see, each and every partition will have 8 bits, right? So class A, you will see first one is 0. So here you can see 0. So its range will be from 0 to 127. It is in decimal notation. So it will be 0 to 127 for class A. For class B, it's 128 to 191. For class C is 191 to 223, 192 to 223. For class D, it's 224 to 239. And for class E, it is 240 to 255. So you can see that 0 to 255, that particular range which we have seen, that range is here also. So 0 to 255. How this particular 0 to 255, how we are breaking this among these classes of addresses, that is, this particular chart is very important. You have to understand this, that what is the range of each and every class, the range of the addresses, which is the starting address and which is the ending address, that you have to keep in mind. Okay, so this table is very important, that IP address beat patterns, how these beat patterns are different, how they are going on, how they are distributed for each and every class, right? Now first is our class A address in networks, that is your, this one is the network and these are the host address, right? So first of all, it's starting with 0. Next, it's 7 bits network address and 24 bits are for your host address, right? So number of networks equals to 2 to the power of 7, that is 128, 0 to 127. Network ID 0 is not used. Network ID 127 is reserved for loopback and is used for internal communication on a computer. Number of networks is 126 and network IDs is from 1 to 126. So this is about the whole data of your class A address, right? It's starting with 0 but it's not used. Again, the number of networks, that is 2 to the power 7, that is 128. So 0 to 127, since it's starting with 0, so 0 to 127, that is total 128 networks are there. 127 is the reserved one for loopback or it's also used for internal communication of computers, and number of networks is 126 and number of IDs is 1 to 126. So this is about your class A address, right? Now next is, here you can see class A address host. It was about the network, it's about your host. Again you can see here the network and the host, same thing. Number of host is 2 to the power 24, that is 16777,216. No host ID can have all zeros, that is 0.0.0, and specific network address. No host ID can have all ones, that is 255.255.255, and specifies broadcast address. Number of hosts per network is 2 to the power 24 minus 2, that is 16777,214. It is about the class A address for host. That was for network and it's for host. Now class B address, it is about class B now. So here you can see the network host 10 is the starting bits is 10, then 14 network bits and 16 are for your host bits. Now host address. Now number of networks here is 2 to the power 14, that is 16384. Number of hosts equals to 2 to the power 16, that is 65,536, 0 to 65535. No host ID can have all zeros, that is 0.0, no, and specific network addresses. No host ID can have all ones, 255.255, and specific the broadcast address. Number of hosts per network is 2 to the power 16 minus 2, that is 65534, right? So now class C. C is about same thing, network and host. You can see 110 is the starting bit, then 21 bits for network address and 8 bits for host address. Number of networks equals to 2 to the power 21, that is 2097152. Number of hosts equals to 2 to the power 8, that is 256, 0 to 255. No host ID can have all zeros, that is 000, that is your 8 bits, and specifies network address. No host ID can have all ones, that is your 8 ones cannot be there, and specific broadcast address. Number of hosts is 2 to the power 8 minus 2, that is 254. Okay, it's about your class C. Now next is about your class D and E, which are reserved. So 1100, that's your multicast address, that's all. Now class D are special addresses that are known as multicast addresses, that is here for your class D. This address is assigned to a group of networks and not to represent an unique address. This is used for a group of networks and not for an unique. Past addresses ABC, they are used for unique addresses, but class D address is used for group of addresses, not for your unique address purpose, right? Now this address is used to send IP datagrams to a group but not to all the hosts on the network. This address is also used to address router update messages, and E1 is reserved for the future use, that is your 111. Starting bit is 111. So this is about your D and E. Now you can see here the address space utilization, how it's used. So 50% is about your A, 25% is for B addresses, C is for 12.5%, D for 6.25%, and also E for 6.25%. Within this you can see the whole address range, how it is lying, right? So this is how the whole addresses are for distributed for your classful addressing. This is the spatial utilization. Now network versus host, class network and host network. Now A has 126 networks, in which host or network is 16777.214. Class B networks are 16384 and host or network is 65354. For C is 2097152 and host or network is 254. In classless environment, we can have 2 to the power 32, that is this much host, 4294967296 host can be there. Okay, for a classless environment where we are not using this kind of classes which we are using now in classful addressing. Now IP address have some restrictions also, right? The host portion of the address cannot be set to all 0 or 1. When you are using the host first portion, your host portion, there you cannot use, the host portion where you cannot use all zeros or all ones. That should be a mixture. Any address with all zeros in the network portion of the address space is meant to be this network. If there is only zeros, all zeros in your network portion, that means it is this network. Addresses cannot be out of the 255 range for each bit. 255 range you have to maintain, you cannot make any address out of that bit. Now what is subnetting and advantages of subnetting? Efficient use of full network address. Security is there to reduce the broadcast traffic. If you have thousands of hosts on a single subnet, your switches will be choking on ARP, DHCP and other broadcasts. Provides for another hierarchy of routing, right? Now this is what is subnetting is. You can see here ABC 0. Again here you can see how this network is there. So here the host is 62, 1 to 62. Here host is 62, again 64 SN2. here 128, and here 192. And here how we are making this masking, subnet masking, right? So it is the whole data how this subnetting is done. Now here how we will make the subnet mask. So IP address is given, this is your IP address which is being given, right? So 172.16.13.12, this is the IP address which have been given. Now default or natural mask, we have to see it is of which particular class, right? First of all, see it is of which particular class, you have to identify that one. Now we have identified this is the what the particular range which we have already studied, so it is of class B. So here the default mask will be 255.255.0.0. Now 8-bit subnet mask is 255.255.255.0. so this is the network, this is the subnet mask, and this is the host. So default or natural subnet mask will be 172.16.13.12 by 16, and 8-bit subnet mask is 172.16.13.12 by 24. Okay, so this is how the subnet masking is done. Now variable length subnet mask. Subnetting creates subnets with equal number of hosts in a network. The number of bits subnetted, that is the length of the subnet mask, will be same for all the subnets. To cooperate with the variable number of hosts in subnets in a network, number subnetted bits, that is the length of the subnet mask for the subnets, will also vary. And the method of achieving subnets with variable length of subnet mask is also known as variable length subnet mask, that is your VLSM. Okay, so this is all about your variable length subnet mask. Now CIDR, that is a classless inter-domain routing, that is pronounced as CIDR. Now RFC 1598, this allocates the remaining class C addresses. Remaining class C addresses means the addresses which have been remained there, which is not used in this purpose, that is used as this particular, this is allocated in remaining class C addresses for this CIDR. Each zone is given a portion of class C addresses where from 194 to 195.2, this is for Europe, 198.000 and 192.25. So but this is for North America, this is for other portions of America, that is Central and South, and here this is for Asia and the Pacific. And each zone is given about 2 into 2 to the power 24, that is 32 million addresses to allocate. This is only for class C addresses which have been, so here this is the range, which range is being maintained for these particular countries, right? So here you can know that which country uses which range of addresses. Now another 20 into 2 to the power 24 320 million class C addresses, that is 204.0.0.0 to 223.255.255.255. These are reserved for the future. Again, class C have sub addresses which are reserved for the future, like class E, right? 32 million address entries have been compressed to one router table entry, that is this 32 million addresses. Any route outside Europe that gets packet address to this can just send to its standard European gateway. Once the packet gets to Europe, 2 into 2 to the power 8 into 2 to the power 8, that is 131072 network entries are needed. If /16, that is subnet mask, /16 bits prefix is used. So if this prefix is used, then only it will, once the packet gets through in Europe, then this network entries are needed. So this prefix is used, that is /16, this subnet mask, this particular prefix is used for Europe, right? So at that time, so this is the particular thing which is about your different subnets. This is a small detailed video where you just get the idea about classless addressing and classful addressing, basically for classful addressing. So this is the data which you have to understand for your IPv4 addressing. I will try to make a detailed video in your classful addressing and classless addressing, so you will have the more data about this particular two things, that is your classful and classless. Till then, this is only a video where you can understand the full concept of classful and classless addressing. I hope you have understood. If there are some type is any queries or any suggestions if you want to give me, you can give me in the comment section. And obviously I will try to make another video where I will give you full details about your classful and classless addressing. Till then, if you have any comments, you can give in the comment section. And if you have been benefited from these classes, then please like, share and subscribe the complete CSC guide. Till then, take care and goodbye.